Hello, my friends. I hope you are doing good. We are back to factoring some more stuff. So, hey, we're going to have some new scenarios today, so we got to be ready for them. Okay, let's see what we can throw at them. So we've done greatest common factor, factor by grouping, and then we had trinomials the other day, and hopefully we're getting pretty good at those. Today we're going to have a couple new scenarios. First one's called difference of squares. This will be the easiest one to recognize right now. Hardest one when we've got all of our polynomials out there and we're trying to factor them. So it'll seem easy, it will be confusing, and we will struggle with it. Perfect square trinomials, we're going to pretend that we don't recognize that they're perfect square trinomials, and we're going to treat them like we normally did with our other. There's the bell, time to go. Okay, we're going to treat them like our other we're going to treat them like our other trinomials, okay? Until you get to see that, well, no, we'll still treat them. Anyway, determine whether each polynomial is a difference of squares. Well, we used perfect squares to simplify radicals, right? That's where we used like 4, 9, 16, okay, all of those. Those were perfect squares. So in a difference means subtraction. In a difference of squares, we are looking for two numbers that are perfect squares, okay? Is this a difference of squares? Well, is m to the second power a perfect square? Yes, it is. Remember, any variable to an even power, 2, 4, 6, 8, 10, so on and so on, is a perfect square. Some of you might argue that there's an invisible 1 in front of there. That's fine. I would argue that the 1 is a perfect square. Is 64 a perfect square? It sure is. Okay. So determine whether each polynomial is a difference of squares, right? Yes or no? If so, factor it. Okay, so definitely this one is a yes. If so, factor it. Okay, this is how they factor, right? We are literally just going to take the square root of both of those. What's the square root of m squared? Okay, that's m. What's the square root of 64? 8. Okay. Make two binomials that are identical. Give them the opposite signs. Plus, minus. Notice how I said that backwards but wrote the other one? Talented. I am. All done. Okay. In order for the middle term, right? We're missing a middle term, right? That we typically saw, right? In the standard form ax squared plus bx plus c. We are missing that dude right there, the bx term, okay? The only way that happens, guys, is if, 1, we have opposite signs in our binomial, and 2, we have the exact same terms, okay? Got to be. Any other scenario will give us a middle term, okay? Yes, all of our difference of squares, when we factor those, will always look like this, okay? All right, factor this one. I really see 4 things on here I want to make sure are perfect squares. Is 16 a perfect square? Yep. Y to the second power, perfect square? 81? Yep. Z squared? Yep. Again, if you don't know if the numbers are, take the square root of them, okay? Now, so yes, sorry, this one is definitely a difference of squares. Take the square root of both terms. So the square root of 16, 4. The square root of y squared, y. Square root of 81, 9. Square root of z squared, z. There's my first one. My second one is identical. Minus, plus. Done factoring, okay? If you want to check it, that's fine, right? You can check your work. Foil that, it will turn into what we have, okay? Difference of squares. Easy to factor once you see it, hard to recognize when we have it, okay? Perfect square, yes. Perfect square, yes. Difference, perfect square, yes. Factor it, okay? All right, so this will factor to 3. B to the second power and 5. 3b to the second power and 5. Again, Our binomials are identical. They just have opposing signs. That's it. We're done. Seems easy. There will be bear traps down the road. I don't know that we'll see any today, though. Okay? So good news there. 25, perfect square. A to the second power, also a perfect square. 36 and b squared, both perfect squares. And we have subtraction. So this is indeed a difference of squares. I know you're going, all right, just factor it. It's fine. Take the square root of both terms here. So this turns into 5a. Take the square root of 36b squared, 6b. Okay? There's your first one. Right? There's your second one. Does it matter if I put minus and then plus? No, not at all, right? The order doesn't make a difference, okay? Here we had the minus in the first expression, addition in the second one. That's fine. Okay? Expression, binomial, whatever you want to call it, folks. Okie dokie. All right. Now we're getting into some good stuff here. So normally when we have two terms, right, just like we've seen, we're always looking for that greatest common factor, right? Just kind of like we do when we have a trinomial. Look for that greatest common factor to make things smaller, make our polynomial smaller, okay? So we might look at this and say, hey, this is definitely not a difference of squares. Not a perfect square, not a perfect square, not a perfect square, not a perfect square, okay? We're probably thinking we're done, okay? So we're saying, oh yeah, greatest common factor. Oh, they both have some x's here. So let me factor that out. Right? Should look like that. However, that wasn't the greatest common factor, now was it? No, there's a, remember, largest number and variable. Okay? We just did a variable there, so I believe we can factor out a 5x. Okay? So let's do that. So this turns into x squared. What is that, minus 4? Okay? Looks pretty good. We should be all done here, right? Somebody said no. Who said? Why did you say no? Oh, they are right. Look, all right, so they said we have a difference of squares. Is that a perfect square? Yes. Is that a perfect square? Mm-hmm. Are we subtracting? Yes, we are. Okay, so let's go ahead and do this then. So perfect square x, perfect square will turn into 2. Make it plus 2, minus 2. All right, here we go. This has to be my answer, though, right? No, it's not. Remember, if you factor out a greatest common factor, just like we did, it's got to still be in your final answer. So we do need to write this here. Okay? Now we're good to go. Okay? So this is my completely factored form. Okay? This is why difference of squares are so sneaky, guys. They will creep up into here, like we think we're done here. And some of us will stop, and then we forgot to look for a difference of squares, right? They are sneaky. They are sneaky. All right. Moving on. Holy cow, we got a lot of these to do. Okay. Determine whether this is a perfect square trinomial. Right, yes or no. If it's a perfect square trinomial, factor it. So a perfect square trinomial, guys, means perfect square, okay? And then if we take the square root of both of these, 5, 3, okay, what's 5 times 3? 15. What's 15 times 2? That number there. If it follows that pattern, okay, perfect square is the first term, perfect square is the last term, and the middle one is 2 times the square root of a times b, then it's a perfect square trinomial, right? And there's a shortcut to factoring it. Would you like to know the shortcut? Would you? Okay, we can do that. Again, if this confuses you, I want you to go back to our 25 times 9, right? What is that? 25 times 9, 175? Whatever that is? No, 225. Goodness gracious, okay? I want you to do that. Go through all the factors of 225 that multiply to positive 225 that add up to negative 30, okay? And go for it that way. For the rest of us, these kind of take the same structure, okay, as we had before. We got to be careful, and we have to use our signs to help me out, okay? So I'm going to take 25 x squared minus that I don't care about, and this. So I'm going to take the square root of 25 and x squared, right? What is that? 5x. I'm going to take the square root of this one. What is that? 3, okay? So it keeps that same pattern. Now, think about how we want to end up here. I want to end up, these two got to multiply to positive 9. However, when we do our outside and our inside terms, they're going to add up to negative 30. So this is where, if you're not really careful and really sure of yourself and being a good factor, you're not going to get the right signs in here. So I would recommend going back and doing this the other way, okay, where we did a times c. That's fine. You're going to get this in the end, okay? So you can write it like this, guys, if you wanted to be super fancy. You could write it like that. It means the same thing. I'd say most of us will probably leave it here, okay? Okay, so yes, this is a perfect square trinomial. Why do we call it a perfect square trinomial? Because it's made up of these perfect squares right here, 25 and 9. Okay? Okay, so that seemed like a lot of fun. Is this one a perfect square trinomial? Well, again, here's what I was talking about earlier. If we take 49 and we take the square root of that, and then I multiply that by the square root of 36, we take all of that times 2, it better equal 42. 7, 6, 2. No, this would be 84. So if it was going to be a perfect square trinomial, that would be an 84. So clearly, this is not an example. So we're just going to write no. Does it want me to factor it? Well, only if it was a perfect square. Hey, we're done there. Heck yeah. Okay. And whether this one is a perfect square trinomial. Well, guys, here's the deal, right? A x squared plus bx plus c. Okay? So we're taking the a term, the c term, right? We're basically going 2 times a times c, right? Is what this b term should turn into. Okay? Again, you just can't take 9 times. That's where some people get confused. I even hesitate to write it down there. Okay? So let's just get rid of that. All right? All right, so here we go. 9x squared minus 12x plus 16. Guys, what is this? Take the square root of this. That would be 3. Remember, 2 times the square root of this times the square root of this. Ooh. 2 times 3 times 4 is 24, not 12. So is this one a perfect square trinomial? No, absolutely not. Onward we go. We get to keep Willow. We just get to skip all of this. I don't think we're going to get to skip this one. Okay? 2 times A times C, right? This is 14 times 2, that's 28. There we go. This is how I know it's a perfect square trinomial. All right, factor it. So again, I'm literally just taking, all right, those, and then I'm going to look at the signs to do a good job here. So 7x and 2, right? This is what my two binomials are going to look like. Now we've got to make sense of what the two signs here mean. So when my 2's multiply together, I have to get positive 4. Okay? Well, they could both be positive, so it could be plus 2 and plus 2, or it could be minus 2 and minus 2. Okay? The middle term is what will tell me which is right. So when we add them together, they add up to a positive 28. So that means plus and plus. Okay? Good to go. Again, you can leave it like that. You can say the quantity of 7x plus 2 squared if you would prefer. I would prefer to be all the way done with these, but we're only halfway done. I'm out. We got geometry. I'm gone. See you guys. Good luck. I'm just kidding. I'm just kidding, folks. We'll solve this one. We got a logo here with dimensions. Great. That helps me not. Write a polynomial that represents the shaded area. It all looks shaded to me. Okay. All right. Area. Okay. All right. I think I'm onto something here, guys. So we have two rectangles, right? Okay. And I know I can find the area of a rectangle if I do length times width, or some of you say base times height. So is there a way that I could come up with an expression for the larger rectangle's area? Yeah, I could do that. Okay. So the larger rectangle, the one in blue, I could probably write this down here. I got probably enough room. All right, so the blue one would be this times this. Don't be confused. This, right, is this dimension right here. Okay? So this times this. All right, so this was 32, 16, right? So the area of this one just happens to be 32 times 16. Is everybody okay with that? I hope so. All right, then we have this other one here. I'll say this is the red one. Okay? All right. And it has side lengths of 2x and x. If I was going to make an expression for the area of this smaller rectangle, again, we would say this is 2x base times height. Right? What is that? 2x squared. Okay. And then it says, write a polynomial that represents the shaded area. Okay, well, here's the shaded area that it's referring to, right? It wants, right? It wants all of this area here, okay? Like this is what it's after. Well, I know this area, and I know the little area, right? Is there a way for me to get the yellow part here? Absolutely there is, right? If I take this area and then I subtract out this red chunk of it, whatever's left has to be, right, what we have in yellow here. So we can kind of put all this together. We can say, hey, the area of that shaded, right, what I had shaded here in yellow, guys, is just this. Okay, it's too late in the day. 32 times 16 is 512. All right, so we're going to take 512, and from that we simply subtract 2x squared. Okay, good to go. I feel like, do we need to factor that? Is 512 a perfect square? Oh, it's not. Okay, nor is 2 though, so that's how we knew we were about to be done. Could I factor a 2 out of this? Could, but really who cares at this point? Okay, so there's the area for the shaded yellow part. Again, kind of tough to see here, but that's what it is. Maybe if we do a few more of these. Factor the oh, so they really did want me to do that. Darn the bad luck, guys. Factor the polynomial completely. All right. I hate when we have to do. Look, that's a great picture there. Okay. So factor this polynomial. So 512 minus 2x squared. What can we do first? Somebody said it. Factor out a 2. No, still too late in the day. 512 divided by 2, 256. Minus x squared. That sounds great, doesn't it? We should be done here, I think, right? What? Did somebody just say difference of squares? Is this a difference of squares? Is this a perfect square? It actually is. X squared, perfect square? Yeah. Difference? Okay. All right. So remember, this 2 is going to be part of my answer, guys. Look, I know it's going to be there. I'm just going to keep writing it, okay? 256 is actually, the square root of that is 16. So 16 and x, right? And then I'm just going to go plus x over here. There we go. So we went from here all the way down to here. We factored it completely. Nice job, people. Proud of you guys, okay? All right, what else do we got to do? Factoring methods, right? Okay, yes. This is all good. Okay. Write prime. That makes Optimus happy when we write prime. It makes me happy because that means we don't have to factor. 96, 6, x squared, okay? I know x squared is a perfect square, but the other two aren't, okay? Biggest number and or variable that we can get out of these two. Well, we can factor a 6 out. This turns into x squared minus 16, doesn't it? Okay. Some of us might be done here. I would argue we are not done because there is, once again, a difference of squares. Okay. This should turn into plus 4 and minus 4. Again, take the square root of each term. Okay. Make your binomials the same, but opposing signs. Make sure 6 is part of your answer. Okay? How about this one? Again, you want to pause the video, you want to try these on your own, you go right ahead. 16, 8, and 15. Let's see, 2 won't go into any of those. Well, 2 goes in here and here, but not there. 3 would go here. No, 4, yes, yes. No. Okay, so I don't think we have anything. Perfect square, not a perfect square, so it's not one of those goofy perfect square trinomials. Dread. Okay, so now we got to do the whole a times c, which I get 240. Okay, so this is, we want numbers that multiply to negative 240. At the same time, they're going to add up to 8. Okay, so remind yourself of this. So if two numbers multiply to a negative, that means one is positive, one is negative. At the same time, they will add up to a positive, meaning the larger of the two numbers will be positive. Okay, so we can start to go through all of this. So the larger number I want to be positive. Okay, so negative 2 and 120, negative 3 and 80. Again, none of these are adding up to 8, right? We need numbers that are probably closer together. Negative 4 and 60, 5, no, 6, and what, 40, 8, and 30. There's a lot of factors going on here, isn't there? 9, no, 10, no, 12, and, well, I'm drawing a blank right now. Holy cow, 240 divided by 12. 20. There, aha! There we go. I was getting nervous. Right, again, as your two numbers get closer, right, that just means you don't have many factors left. All right, so rewrite 16y squared. Again, I'm only rewriting the 8y with those two. So I'm going to go minus 12y plus 20y. Keep this number, not this one. Okay? Factor by grouping. We are home free. Okay. 4, I think. Y, I believe. This should turn into 4y minus 3. You guys okay with that? Hope so. Let's see. I should factor out a 5 here. That will turn into 4y minus 3. We are good to go. These match up. They're half of my answer, 4y minus 3. The other half comes from my two factors, 4y plus 5. Okay? All good. You want to double check your answer? Fine by me. Go ahead. Foil that right on out. Factor this one. Greatest common factor. What do you guys think? Yup, it's definitely a 3. So we're going to factor a 3 out. Should look like that. I believe we're all done. But we're not. This is the sneakiest difference of squares we have, okay? Is this a perfect square? Is that a perfect square? It is. Don't forget, 3 still is part of my answer. So this is going to turn into x plus 1, x minus 1. Oh my goodness. Okay? So yes, there you go. Now you're done. Now you're done. Unlike these notes, which still are not done. Okay. Is this a perfect square trinomial? 4 perfect square, 6. Oh, darn the bad luck. But I can factor out a 2, right? That's somewhat worthwhile. 2x squared plus 5x plus 3. Again, do you have to do this? No, but it just makes for fewer factors. When I go 2 times 3, which is 6, right? So I want numbers that multiply to positive 6. At the same time, they add up to positive 5. Okay, so think about that. We've got to be 2 numbers, right, that multiply to positive 6, like positive 1 and positive 6, positive 2, positive 3. Ah, there it is right there. Okay? Okay, so 2. And then we're going to have this 2x squared plus 2x plus 3x plus 3. Okay, then I'm going to group those. 2 is just hanging out, right? Eventually, we're going to do something with that. This will turn into 2x, which is going to be x plus 1. We will factor out a 3. This will also be x plus 1. Okay? Write all of your answers. So 2 times the quantity 2x plus 3 times the quantity x plus 1. All done. Okay. Work for you guys? Works for me. Holy smokes. So notice nothing was primed there. Okay? Again, they're always going to say if it's prime, write prime. Doesn't always mean it's going to happen though. Okay? All right, so factor this. The only thing I can think of is if 625 is a perfect square, which I do believe it is. What is that, 15? No, 25. 25. Okay, so take the square root of both of these. Well, this is y squared. This is 25. Again, these have to be identical. Y squared and 25. I'll make this one plus, that one minus. Good to go. No, it's not. No, it's not. We can keep going. We can keep going. A lot of times on your homework, right, you'll see me put keep going, right? Can I keep going here? This is, look, perfect square, perfect square, perfect square, perfect square. Only one of these is a difference of squares. People, this one here. This one is done being factored. Okay? Done. I'm going to try to trick you at some point in time and say factor this. And then we'll have to sign in with my Apple ID. Let me make that go away. Don't know why that popped up. Right? I'm going to try to trick you. All right? It is your goal to put down prime. If all I gave you was this here, guys, this can't be factored. This can be, right? We know this should factor into y plus 5 and y minus 5. And then y squared plus 25. Again, you cannot leave out this from your answer. It's still, this is not my answer because this would never turn into that. Okay? All right. 256. I believe that to be a perfect square. What is that, 16? We know that n to the 4th power is, yep. So again, first step here says, hey, 16 minus n squared, 16 plus n squared. Only one of those is a difference of squares. Keep going. Right? That one's my difference of squares. Okay? 4 minus n, 4 plus n. Don't forget what you started with. Okay? I promise, guys, these will get easier the more and more and more we do. Okay? So, I know that was a lot. I appreciate your effort. Okay? Good luck. See you soon.